You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Security Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. User Behavior Analytics, often referred to as UBA, or its broader term UEBA, User and Entity Behavior Analytics, is a security discipline that focuses on detecting anomalous actions by people and devices. Instead of relying solely on known indicators of compromise, UBA examines how users and entities normally behave and highlights deviations that might indicate insider threats, compromised accounts, or advanced attacks. Its goal is to catch subtle patterns that rules-based systems often miss, providing a behavioral lens into risk. Hardened organizations deploy UBA to complement traditional monitoring, adding depth by focusing on the who and how behind activity rather than only the what. There is a critical difference between traditional signature or rules-based detections and behavior-based detections. Rules and signatures catch specific, known threats, such as a malware hash or a login from a blacklisted IP. These are powerful for well-understood attacks, but blind to novel techniques. Behavior-based detection looks for unusual patterns, like an employee suddenly accessing thousands of records they normally don't touch. Instead of asking, "Does this match a known bad thing?" UBA asks, "Is this normal for this user or entity?" Hardened organizations use both approaches together, leveraging signatures for precision and UBA for adaptability. UBA relies on diverse telemetry sources to build meaningful insights. Authentication logs reveal when and where users log in, highlighting anomalies like access from strange geographies. File access records show which documents or directories are touched, providing visibility into unusual data interaction. Process events help identify when users launch suspicious or rare applications, and network flows reveal communication patterns. Hardened organizations collect this telemetry systematically, treating it as the raw material for baselines and anomaly models. Without broad, consistent data, UBA cannot distinguish the normal from the suspicious. Baseline modeling is the foundation of UBA. By observing activity over time, systems build profiles of what is typical for each user, role, or device type. For example, a sales manager may typically log in from one region during business hours, while developers may use specific repositories after hours. Baselines account for these variations, ensuring alerts reflect true deviations rather than expected behavior. Hardened organizations allow baselines to evolve, using rolling windows to adapt while preserving enough history to catch gradual shifts that may signal malicious adaptation. UBA is designed to highlight anomalies that matter. Common flags include impossible travel, where logins appear from geographically distant locations in implausible timeframes, suggesting credential compromise. Privilege abuse is another, such as sudden administrative actions by accounts that rarely use elevated rights. Unusual data access patterns like downloading far more files than normal can reveal insider threats or compromised accounts exfiltrating data. Hardened organizations train models to prioritize these types of anomalies, focusing analyst attention on activity with high potential impact. Entity baselines play a different role than global baselines. Global baselines capture organization-wide averages, while entity baselines reflect what's normal for an individual or small cohort. Without entity baselines, a developer downloading large amounts of code may always look suspicious compared to an HR staffer. Entity-specific modeling reduces noise by considering what is normal for each group. Hardened organizations balance both approaches: global baselines for broad anomalies, entity baselines for context-specific accuracy. This balance prevents false positives from overwhelming analysts. Scoring and risk aggregation transform weak signals into strong alerts. A single unusual login may not warrant escalation, but combined with an anomalous download and a suspicious process launch, it paints a compelling picture. UBA assigns scores to each signal and aggregates them into a risk score for the user or entity. When thresholds are crossed, alerts are generated. Hardened organizations design scoring carefully, weighting high-value assets more heavily and ensuring that risk is contextualized. This aggregation ensures alerts reflect patterns, not isolated oddities. Training data is essential for building accurate behavior models, but it must be handled carefully to avoid bias. If baselines are built on too narrow a dataset, models may unfairly flag legitimate behaviors as anomalous. For example, a new employee's activity may look suspicious simply because they lack history. Hardened organizations design UBA models to adapt, using cohort comparisons and supervised learning to reduce bias. Regular reviews of training data help ensure models reflect organizational diversity rather than penalize it. Enrichment practices enhance the value of raw UBA signals. Adding role information clarifies whether a privileged account is involved. Departmental context ensures anomalies are compared to the right peer group. Asset criticality highlights when activity involves sensitive systems, and geolocation reveals unexpected travel. These enrichments turn simple events into actionable intelligence. Hardened organizations integrate enrichment pipelines automatically, ensuring analysts receive context-rich signals that can be triaged quickly and effectively. Poorly designed UBA models often fall into common pitfalls. Overfitting to short windows makes models hypersensitive, flagging harmless fluctuations as suspicious. Undertuned models generate alert fatigue, overwhelming analysts with irrelevant noise. Hardened organizations combat this by using long enough baselines to capture seasonality and by continuously tuning thresholds. They view UBA as a living system requiring adjustment, not a one-time deployment. This discipline ensures alerts remain credible and useful rather than becoming distractions. A concrete way to begin with UBA is to pilot with a specific user cohort, such as the finance team. Collect 30 days of authentication and file access logs to build baselines. Then define two anomaly rules, one for off-hours access and another for unusually large downloads. Evaluate how often alerts fire and validate false positive rates with the help of investigators. Hardened organizations use these small-scale pilots to refine approaches before expanding UBA enterprise-wide, ensuring the system delivers value while maintaining credibility and precision. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Anomaly scoring thresholds determine how aggressively a UBA system surfaces alerts. Low thresholds may overwhelm analysts with minor deviations, while overly high thresholds risk missing genuine threats. Calibration involves testing thresholds against historical data to see which values yield meaningful alerts. Some organizations start in alert-only mode, flagging anomalies without taking action, and only move toward automated containment once confidence is high. Hardened environments tie thresholds to risk categories. Mild anomalies generate monitoring, while severe or multi-signal anomalies may trigger containment playbooks. This tiered approach balances vigilance with operational practicality. Correlation of UBA signals with endpoint and network telemetry raises confidence dramatically. A single anomaly, like late-night data access, may be benign on its own. But when combined with EDR logs showing new processes or NDR data showing unusual connections, the likelihood of compromise rises significantly. Hardened organizations ensure UBA is not a silo but a layer feeding into SIEMs and SOAR platforms where it enriches other telemetry. Correlation transforms weak, noisy signals into strong indicators, giving analysts clearer context and reducing wasted effort. Playbooks bring structure to common UBA detections. For example, suspicious downloads may trigger workflows that quarantine the endpoint, notify the data owner, and scan for additional anomalies. Credential misuse could prompt forced password resets, token revocations, and privilege reviews. Lateral movement alerts might lead to VLAN isolation, enhanced logging, and red team-style validation. Hardened organizations document these playbooks in detail, automating steps where safe, while keeping analysts in the loop for decisions that affect business continuity. This ensures UBA detections are actionable, not just informative. Tuning approaches keep UBA relevant as environments change. Rolling baselines allow models to evolve, capturing shifts in user behavior over time. Seasonal adjustments account for predictable fluctuations, such as spikes in retail activity during holidays or quarterly financial reporting surges. Cohort-specific models reduce false positives by comparing users to peers in similar roles. Hardened organizations treat tuning as an ongoing process, embedding cycles of review and refinement into operations. This continuous adjustment ensures UBA remains effective and avoids degrading into noise. Feedback loops connect analyst decisions back into UBA models. If an alert is deemed benign, that verdict should feed into retraining processes to suppress similar false positives in the future. Conversely, validated alerts should reinforce model weightings to strengthen detection. Hardened organizations design structured feedback channels, capturing analyst notes and investigation results automatically. This creates a virtuous cycle where UBA models improve over time, reducing workload while sharpening accuracy. Privacy-preserving techniques safeguard trust when analyzing user behavior. Pseudonymization masks direct identifiers during processing, with real identities revealed only when necessary. Aggregation reduces the granularity of data, surfacing trends rather than raw actions where appropriate. Limited retention ensures behavioral data is not stored longer than needed. Hardened organizations implement these techniques to comply with regulations and maintain employee trust, proving that monitoring can support security goals without creating surveillance cultures. Combining supervised and unsupervised models enhances coverage. Supervised models detect known behaviors by learning from labeled datasets, making them ideal for familiar risks like brute force logins. Unsupervised models surface novel anomalies by clustering behaviors without pre-labels, catching previously unseen attack patterns. Hardened organizations deploy both, ensuring defenses adapt to both known threats and emerging adversary techniques. This hybrid model avoids reliance on a single detection method, strengthening resilience across diverse scenarios. The investigative experience determines how useful UBA alerts are in practice. Analysts must see timelines of user activity, correlated events across systems, and suggested triage steps. Well-designed displays make it easy to trace anomalies from login to file, access to network activity, providing a coherent story rather than disjointed events. Hardened organizations prioritize UX design in their UBA tools, ensuring investigations are intuitive and efficient. This reduces analyst fatigue and increases trust in the system's outputs. Metrics allow organizations to measure UBA's value. True positive rate highlights detection accuracy, while false positives show efficiency. Reduction in dwell time demonstrates how quickly compromises are discovered, and analyst time saved indicates operational impact. Hardened organizations track these metrics to justify investments and refine processes. By making UBA measurable, they move it from a promising technology to a proven contributor to security outcomes. Risk-based response ensures alerts tied to high-value assets receive faster escalation. A suspicious login on a kiosk device may merit observation, while the same anomaly on a domain controller demands immediate containment. Hardened organizations tag assets with criticality scores and prioritize UBA responses accordingly. This ensures limited analyst time is spent where it matters most, protecting crown jewels rather than being consumed by low-risk noise. Integration with SOAR platforms automates safe containment when UBA detections reach high confidence. For example, if UBA detects impossible travel combined with abnormal downloads, a SOAR playbook might revoke sessions, isolate the endpoint, and notify managers automatically. Human oversight remains for ambiguous cases, but high-confidence detections move quickly into action. Hardened organizations use automation to scale, ensuring UBA not only detects but also drives timely containment. Ultimately, UBA becomes a force multiplier when it is carefully tuned, privacy-aware, and integrated with broader telemetry. It adds behavioral context to traditional detections, catching insider threats and compromised accounts that signatures miss. When supported by feedback loops, privacy safeguards, and automation, UBA shifts from experimental technology into a reliable component of security operations. Hardened organizations recognize its power not as a standalone tool, but as part of an ecosystem that blends human insight with machine-driven analysis for faster, smarter defense. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.